All right, so I'm gonna go ahead and create a dummy app here, just the default one. So I'll create a directory. All right, and just this. That's fine. And this will be React, and we'll use boring old JavaScript. All right, so I'm gonna now cd and npm install. So I'm gonna check this out on the side here. All right, so this what is app? I guess there's a couple ways to answer that question.
I was going to say it's a function.
Yeah, yeah. So at a very basic, excuse me, a very basic level, this is a function. So it's literally a function. They use capital letters instead of lowercase. So this is a little unconventional. But yeah, it's app is just a function. So a component is a function, and you can have lots of different components, which are all going to be functions. And then in this example, there's just happens to be just one at the top level, but you can have lots of other components, and then app can include those, so it can call those functions inside of it, and they will ultimately produce HTML and JavaScript. But this, what we're writing, even though this looks like HTML, it's not actually HTML. It's actually JSX. Um, so you can, the developer experience of writing React is familiar if you know HTML, which we do. But React is actually going to take this and transform it. It will ultimately spit out HTML, CSS, etc. So you can look here in the elements, and it's ultimately whatever goes to the browser is going to be JavaScript, HTML, etc. We can actually let me go to package.json, and I'm going to go ahead and build the project, and we'll see what that looks like. So as we're developing, we're kind of using React, all the React magic that we don't need to worry about, but that comes with React. But ultimately, when we deploy this on an EC2 instance and serve it up to clients, what we serve up to clients is not going to be React. It's going to be HTML, JavaScript, CSS. And in order to translate all of this stuff, all of these components that return JSX into HTML, CSS, and JavaScript, you're going to have to build it. So I'm going to run this command. So npm run build. And it's basically, if we go up here, it's going to create a folder called dist, which you can look at, and it's going to have an index.html, which should look very, very similar to what you actually have right here. So notice we have a head, blah, blah, blah. We have a script, and we have a style sheet, blah, blah, blah. And we have one div, which is the root div. And everything is going to get connected to that. So here is the JavaScript. And this is not very user friendly because this has been totally transformed and minified and blah blah blah. But if we look at the actual code here, what do we have? We have count. So I'm just going to search for count in here. Might not be able to find it. Let's see. Might have got renamed. Okay, so right here, we have a function, children count is blah, blah, blah. So you can, you can see that what you wrote actually gets translated into all this stuff. But you really don't need to worry about that process, but just as a, conceptual background, what we're writing is actually functions that return JSX, and React will handle transforming all of that into something that browsers can understand. Okay, so this is running. Can anyone tell me, so we know what a component is. A component is basically a function that returns JSX, and components can be reusable. So you can have the same component. You can put 30 copies of the same component into one view or page. What about state? What is state in a React context?
It's used to be able to dynamically update the page without reloading.
Okay. Yeah. So yeah, it's used to dynamically update the page. So state is used when you want something to change. So if you have something which is changeable, then you want to put that in state. And who owns state?
The component?
Yeah. Yeah. So state will belong to whatever component has it, right? So you can have lots of different components and they can have their own state, but that state is purely internal. It's separate from every other component state. So if you change the state in one component, that's totally independent from a state change in another component. So if I write a component and I have something which is changeable, and it could be changeable for any reason, in this case, based on a user action like clicking this button. But it could be, anything. Basically anything that needs an event handler. It can also be, stuff you get from an API. You want to put that in state because that's also something that can change. So if I make one request, I get one result. If I make another request, I get a different result. So anything which can vary or change is going to be state. All this other stuff is not going to change, so it doesn't need to be in state. Okay, so I'm also going to, have you guys been using the React DevTools?
No, we haven't.
Okay. I would strongly recommend installing the React DevTools extension for your browser. It makes developing way easier. So I have that here. So because I have that here, I have these two things available to me. So I'll click on components, and you can see that we just have one component, which is app for right now. So you can click on app, and then you can see the props that it takes, which in this case, there are no props, right? So what are props?
They're like immutable properties of a component that you can pass to children.
Yeah, yeah. So props are a way. So state is for information that can change within a component. But if you have a component that needs to change based on information from a parent, then you use props. So props is a way of passing information from one component to another component. So state is purely internal to a given component, and props is a way, it's a way to pass information from one component to another. Are there any restrictions on how that information passing works? Can any component pass props to any other component?
I think you can only go parent to child, right?
Yeah, yeah. So props can only get passed down from parent to child. So one reason to use the React Dev tools, it doesn't really matter now because it's a single component. But once you start building more complex things, your your application is going to be a hierarchy of components. So it'll be a tree. You'll have app at the top, and then you'll have, app will have one or many children, and those children can have children, and so on. And so as you're designing and implementing React apps, you'll find eventually that you'll kind of be working on something and you realize, hey, this component needs some information from another component. And so you have to think about the structure, the tree structure, the hierarchy of all these components in order to make sure that you can do that. So that's kind of what we're going to focus on today, but we'll continue the review for a second. All right, so looking at the code here, so I have this. Actually, before I say that, so props. If a component is a function, what are props?
Be like inputs or like I like the what you put in the parentheses of functions. I'm
Yeah.
blank.
Yeah, exactly. So, parameters or arguments, right? So if a component is a function, then props is just an argument that you pass to the function when you call it. So, this looks like a huge complicated thing, but at some level it's just a function, and then the function can either take no parameters or it can take, any number of parameters. Okay, so I have this state here. So I know, just looking at the code, I know that count is something that is going to change. So when and how does count change?
It changes using the set count function. And
Yeah.
On click in this instance.
Exactly. So this use state hook, we're calling it right here, and it returns two things. It returns the count, which is, whatever value that you want. And then it also returns, what is this? What kind of thing is set count?
It's a function.
Yeah. So what's the signature of use state? I'm gonna call on Jordan. What's the signature of use state?
0.
Okay, yeah. So we happen to be passing in a specific value here for use state, but when I ask about signature, what I'm asking is what are what does it take as input and what does it return?
So does it take the on-click function and then return the new count?
So just looking right here at the use state function itself. So what does it return?
The new count.
Yep. So what's the if we're talking about like types, right? So at a
Oh, so
at a
like an
basic level.
integer.
Okay, good. And
then this function.
yeah, so use state returns some value. In this case, it'll be an integer, but it could be anything. So it returns some value and a function. And what does it take as a parameter?
An integer, which is the 0.
Yeah, so it could take anything, right? In this case, it's an integer, but it could be a string, it could
Anything.
be an object, it could be anything. It could also be nothing. So use state takes 0 or 1 arguments, which could be any value, and returns a tuple, it returns an array, whatever. It returns 2 things, which we are destructuring here. What's an alternative? What's an alternative to this shortcut syntax?
I'm not sure.
Sandy. If let's say this is, older JavaScript and we don't have this fancy destructuring on one line syntax.
Yeah, I think I'm just as confused.
Okay, so if I write, so actually let me just go here. All right, I'm gonna write a function. It's gonna take, we'll just say it takes an argument. And I'm gonna return, it's gonna return, let's say A, and it will return a function. I'll just say it. Okay, so now if I want to call this and use the return values, how do I do that?
You would set a new variable to the function
Okay,
with the argument you want.
and then what if I want to get the actual value that I care about?
Set it to the first index.
Yeah, exactly. So const val equals stuff at 0, const func equals stuff at 1. So that's the same thing as const so this is the same thing as this. It's just shorthand syntax. Okay, so use state takes 0 or more parameters and returns some value and then a function. All right, so when we actually want to use this, we want a specific action to happen, which is going to result in changing state. So we have an event listener, which in this case is going to be on click. And then on click takes what? What kind of thing does on click take? Or, you know, and event listener.
A function.
Exactly, yeah. So on click will take a function. In this case, we're using an anonymous inline function, but you could, you know, give it a name and do whatever. It will also take an optional event parameter, but we don't care about that. So we're just not going to pass it in. And that's going to call set count, which is this function right here. And what is the signature of set count?
It just takes in an int and returns an int because it's the count and then the count plus one.
Okay. So if we have what kind of thing are we passing into set count right here?
An integer and a function. Oh yeah, just a function.
Yeah. So we're passing in a function. So set count can either take just a value or it can take a function. So we're getting into, like, you know, function hell basically. But so use state, you call it, which is a function. It returns a function. That function can also take a function, right? So, and it's being passed in here, which also takes a function, which calls the function, etc. So it's just functions all the way down. So we have a function here, and you don't need to worry about this too much, but so these set whatever functions for your state can either take just a value or they can take a function. And how do you know when you should use either pass the value directly or call a function? If the updated state depends on the previous state, then you pass in a function. And it's just because that's how, like, React isn't going to directly call this stuff. This stuff is going to get sent to the, you know, React magical engine, which is going to do some processing. So it's just a way of making sure that things stay in sync. But because this count, like, when we click it, it's going to start at 0. When we click it, it should increment to 1. But that 1 is dependent on the previous state, right? So if the previous one is 0, then when I change, it's going to be 1. If I change it again, it's going to be 2, which is dependent on the previous state. So sometimes you'll have state which is basically like building up on some previous state, and in which case you'll pass in a function. Otherwise, you can just pass in a value directly. Okay, so if I actually call this now, I can actually see, so one nice thing about the dev tools is that you can see what your state actually is. So as you're developing, you know, you might want to separate how it actually displays with what are the actual values that I have, right? So you don't have to, you can decouple those things, which makes it easier to debug. So you can see the state here, the actual state is 1, and maybe I have a bug here where, you know, count is right. So I have a bug here, and every time I click it, I'm expecting, hey, the count should be updating. What's going on? Maybe, so you don't know what the problem is, right? Is it a problem with your state? Is it a problem with something else? Is it a prop coming in from somewhere else? Blah, blah, blah. You don't really know if you're if you're just going through the visual representation layer, but if you can use the dev tools, you can go directly to the information that you care about and see, okay, my state actually is updating properly. It's just not displaying. So it allows you to focus on the problem. Okay, so yeah, that's kind of the basic review. Any general questions about that? Okay, all right, let's get into today's stuff. So today's stuff, we're gonna look at a React pattern, basically. So React has certain things you have to know about and care about. You have to know about components, you have to know about state, and you have to know about props. That's like 95% of what you need to know to do React. So I need to make components. And in those components, you could have one giant component. You could, just like when you're writing code, you can just have one giant 500-line function that does everything. Probably not a good idea, but you can do that. You can also break things up into very small components. So looking at here, this is all being rendered as one component, but all these things, this could be a component, this could be like a footer component, this could be some like, informational component, this button could be a component, this header could be a component, this, image section could be a component. All these other things could be individual components. We could put those in their own files and organize it, make it very small and modular. So if we had another page, let's say like all of our pages, we want to have some kind of, image displayed. You would just create a component that displays an image, and then you can reuse that anywhere else. Okay, so right, so we've done this. So what we're going to talk about now is what happens when you start having lots of other components, not just one, but you have lots of other components, and then you find yourself in a situation where you need one component to give information to a different component, but because of the rules of props, you can only pass things down in the hierarchy. So you basically have to reorganize your component hierarchy and move some stuff around in order to make that work. So that's the basic idea. It sounds a little abstract, maybe. We'll look at an example, and you'll definitely encounter the situation as you write more React. All right, so let's start with this code right here. So this might look familiar. We have a to-do app, and I'm gonna always basically use the dev tools. So I can see here, what's my state? I have item 1, item 2, item 3, and if I add another one, it's right here, and it shows up in my state. So I can see it displayed, I can see it in the state, everything lines up. So I'm good, basically. All right, so let's take a look at what this is actually doing. This. Okay, so we have our app component. We have some state. So what do I know about this right off the bat?
That we're going to use this to change what's being displayed.
Yeah, so I know that to-dos is something that can change, right? So I'm starting off with, I happen to be starting off with this hard-coded list of values, but if it's in state, I know that to-dos is going to be changeable. So there's going to be some way that to-dos changes, whether based on some user interaction, or maybe I have like a random timeout that generates nonsense and changes. However it happens, I know that to-dos can potentially change. Okay, and down here, what am I doing right here?
And you're using the map function, but it's basically doing like a loop through the to-dos and then doing something with them.
Yep. Yeah, so the job of this is to take whatever to-dos is, and when this component first renders. So by the way, we like in React, you'll hear this term render all the time. Render just means call the function. So call the app function. That's what a render is. Call the function and display the result. So anytime to-dos changes, what's going to happen? So any
Vectors, it reruns that those lines of code and kind of re-renders.
yes, yeah. So in React terminology, yeah, it will trigger a re-render. So a change in state will trigger a re-render. In more general terms, it's just going to call this function again. So a re-render just means call this function again. And if I change to-dos, it's going to call the function, and then to-dos is going to have a brand new value. So every time I call the function to-dos, I'm going to get a brand new copy of this. So if we're thinking about functions, it's not entirely true, but it's basically a pure function. So I have something, and every time I call it, I create a new one. So what's the alternative to creating a new thing every time?
Just modifying the existing.
Yes, exactly. So if I have a thing and I want another thing that's different, I basically have two options. I can either create a brand new thing, which has my new desired state, or I can mutate or modify the original thing to that. So we'll look at an example right here. So if I want to double every number, and I want my R to be 2, 4, 6, I can do that in two ways. Basically, I can take this array and I can create a new array that has those new values 2, 4, 6, or I can keep this and mutate these so that the array reflects what I want. So the two basic ways you can do that in JavaScript is for each and map. So if I start with my r dot for each, in this case, num and the index, I'm going to say my r at I equals num times 2. So I'll assign this to actually. So what does for each return? If I console log for each return, what am I going to see?
Each number in your array doubled.
Okay. Any other hypotheses before the big reveal?
They return a new array. I can't remember.
Okay, let's see. Oh, sorry. CD. Undefined. Interesting. So what does for each return?
Nothing.
Yeah, it doesn't return anything. So in JavaScript, that's undefined. What about if I log my R? What is my R gonna be?
It stay the same, maybe.
Okay. Let's see what happens. It's 246. What if I log this up here? What is my R gonna be?
1, 2, 3.
Yeah. So if I log it up here, it's 1, 2, 3, and then I have this line, which mutates this, and then if I log it after this line, I'm gonna have the mutated value. But for each just does side effects. It's side effect. It's an impure function. It does side effects. The pure version of this is map. We do basically the same thing. So my R dot map, and it's actually a little simpler here. So we can just do num times 2. And if I console map return, I'll comment this out for now. I get 246. I can also console log the original array, and it's still there. 1, 2, 3. So I haven't modified this. I just used this to create a new array, but I didn't touch it. I didn't change it. So this is a pure function. We've created a brand new array, kind of using the old one, but not actually modifying the old one. And so now going forward, I don't have to worry about this anymore. What if I leave this line in? Now what am I going to see here?
246, 246.
Okay. Any other guesses?
Actually, wait, and the map will then double it again.
Yeah. So we get 246 and then 4, 8, 12. Because we have this array, we mutate the array, Now we're creating a new one, but it's based on the mutated array. So imagine if this line were not just right here, but you know, you have a code base with 500 files in it, and somewhere this line gets run, or this line gets run occasionally. And now you have a problem where somewhere else in your code, you're trying to use this value, but it's not what you expect it to be. So debugging that kind of stuff can be a nightmare, and that's one reason why you want to avoid avoid mutating things. Once I create it, I know that that's what it's going to be. That's what it's going to be, and that's always what's it's going to be. So that's
Is there,
yeah.
is there a scenario where you would want to use for each?
Yeah, definitely. So I mean, there are a few reasons. So the like basically creation versus mutation debate. You know, there are reasons you wouldn't want to do it. One, you know, we're now creating more stuff all the time, so that can be more resource intensive. So if you're trying to do really efficient things with limited resources, then yeah, you're probably going to end up using mutation. But as a general like best practice for coding in terms of like avoiding errors and making your code easier to understand, it's best to avoid mutation. So the people at React want React components to be pure. So if you look through the React documentation, you'll see, you know, pure components. And that's what this means. A component is just a function, and pure just means it's not mutating stuff. So a pure component is a function which, in this case, returns a brand new thing every time. Okay, so every time a re-render gets triggered, i.e. every time this component gets called, it's going to get a brand new, it's going to have its own brand new to-dos, right? And that to-dos is going to get mapped through and it's going to render. And then if I change it, let's say by adding a new to-do here, it's going to change the state, which is going to tell the React engine, the React magic, hey, you need to call this function again with a new value. So I now have basically a brand new, so when I click that button, it triggered this onSubmit event handler, which called this function, which called the set to-dos, which changed the state, which told the React engine, hey, you need to call app again. And it called app again, and it gave it that brand new updated to-dos. And then the return value, it mapped over, created all the JSX and returned that, and then displayed it. So that's, I mean, that's basically what's happening. You don't have to like necessarily think through all those steps every time you're doing stuff. But that's kind of how it works. These are just functions, and they get called anytime this changes. It's call this function, but we want everything to be pure. So don't change anything. Just give me a brand new value, call the function with that new value, and return it, and that's it. Okay. All right, why don't we take a 5-minute break? All right. All right, so yeah, just been familiarizing ourselves with this and how, again, how kind of React works at a general level. All right, any questions about this right now? All right, so we have this one giant, giant in quotes, giant component. And if we look at the UI here, you can see that there's definitely room to break this up into smaller components. So we have a button, we have a text input field, we have an individual to do, we have like a container of to-dos. So there are a number of possible ways we could break this up. You can go, you can break it down very, very small or more high level. So we'll just start with a more basic breakdown first. So we'll have a submit to do and display to do components. So I'm going to copy this, and then React doesn't enforce any particular organizational system on you, but it's a good idea to have something. So we'll create a components folder, and then we'll put some stuff in here. So we have a submit to do. I can paste that in. And then we're going to have a display to dos. Okay, put that in. And then our app.jsx is going to be a little more bare bones. All right, and let's see if that broke anything. So everything should work exactly the same way, and it should look exactly the same way. All we did was reorganize the code itself. So let's make sure this works. It does work. And notice over here, so visually nothing has changed. And also, in terms of functionality, nothing has changed. But over here, now we have, we can see the actual hierarchy, the tree, the tree of all of our components. So app is at the top level. App is now kind of dumb. All it has to do is render this other component. It's kind of doesn't have any state, it doesn't take any props. And then we have this submit to do, and this submit to do now has some state. So looking at submit to do, it's now got state. It handles updating its state, and then it displays stuff. So it has state, but not props. And then finally, display to dos. Display to dos takes in props, but doesn't have any state. So we can see that here, display to dos has props, but there's no state. Okay, any questions about that? All right. So we could imagine a scenario where we want, let's say, both of these components. Right now we have this hierarchy. We have app and then submit to do, and that's where our state is. And then we have a child here, display to dos, but we might not want display to dos to be, dependent, to have to be a child to submit to do. We might also want whatever that state is. So we'll see that later. We want that state to also be passed to other components, and we don't want to have that tied in there. So what we'll do first is make these components sisters. So instead of submit to do being a parent of display to dos, we'll make display to dos a sister of submit to do. How do we do that? We'll take a look. So the basic answer is you push up state into a common parent. So the common parent at the moment for these two is app. So in order to make these sisters, and because submit to do has state, we have to push that state up one more level, to app. All right, so we're going to go to app. So now app has all of the state controlling stuff. And we'll go to submit to do. And then display to dos. And we can go back here to the app again. Nothing should change visually or in terms of functionality. So all this stuff should be the exact same, but now our hierarchy has changed. So we have app here at the top, and now app has state. App has the state, and it can pass that state down into anything that to any of its children that need that as props. So now display to dos gets props, which it had before anyway, but submit to do also gets props. Submit to do actually gets 2 props. It gets the to dos and it also gets this function. So the way that you get around, so this is basically like a loophole. So the restriction with props is that information can only flow down. So if I have some information in app and I want to pass it to display to dos, I can pass it down. I basically call the function, right? So display to dos is a function that gets called by app. So if it gets called by app can give it some parameters. You can pass in values as props and call this function and it will display. But since app is responsible for calling display to dos and submit to do, I can't have information from display to dos. I can't pass in information from display to dos to submit to do, right? These are like two functions on the same level. If I want to call them from outside, I can't, I can't control one from the other. So props has to go from top down. So how do you get around that? Because I actually want, information from submit to do to get passed to display to dos. So in app, we have all of our state and we have the function which updates the state, more or less directly. And what I do is I basically, app controls all that stuff, but I can pass the function that can change that. I pass that function down as a prop to submit to do. So it's basically a loophole. So now submit to do can, indirectly change the state of its parent component. So looking at submit to do, it takes 2 props. One is to dos, which it's not doing anything with. And it takes this function handle submit. So anytime someone clicks the button, it's going to call this function, but it doesn't really own this function. It just gets passed in as props. And then when this component calls this function, the state in app gets updated. So that triggers a re-render of app with this new state. And when app gets re-rendered, guess what else gets re-rendered? Display to dos and submit to do. So because app gets re-rendered because of a change to dos, it will now call these components and will pass in the updated to dos values. Are there questions about that? So it's definitely complicated, but it's if you do enough React stuff, you'll just get used to it because it's really the same kind of thing over and over again. All right, so let's kind of make this a little bit more meaningful by adding another component. So we're going to add another component, which is going to tell us how many to-do items we have. It's going to give us a total of to-do items. So I'm going to create a new component here. And this is also just going to take props. It doesn't need to really do much on its own, but it's going to take props and it's just going to render the length of those props. And then I have to make sure and update app.jsx to actually render that. Oh yeah, let me just modify this file. Okay, so app is now gonna render to-do count, which is gonna take to-dos, display to-dos, which is also gonna take to-dos, and this actually doesn't need to take that, but we'll just leave it for now. And then submit to-do is gonna get this handle submit function. So this component, which is a sister of these other two, is gonna actually call the function, which will then update the state, which will then re-trigger a re-render of all of these. So submit to do is changing the state of its parent, which allows all of that information to flow down. All right, so look right here again. Again, this should look exactly the same, except now we have this other thing. You can see that the total count is 3. We add another one, and now the to-dos count is 4. And we can look at the actual structure to make sure that it reflects what we're expecting. So the to-do count, it only has props, no state. Display to-dos, again, only props. And then submit to-do has this props, which we're not using at the moment. And then it also has this function, which is going to change the state of its parent. So that's how you handle what they call lifting state. If you have multiple components that need to share state, you put that state in a common parent, and then you can pass a function down to whichever component needs to change it, and then all the props can then filter from the common parent down. Any questions about that?
So it seems like definitely have to spend a lot more time kind of sketching out your plan or idea of what's going to be the parent and relationships and stuff. Is there a kind of like a tool, kind of like quick databases that we use that kind of helps you sketch it out, or is that just kind of pen and paper or in your head that you do it?
Yeah, that's a good question. I don't know of any specific tools that do that. It's also something that like as you're planning things out, you'll definitely want to think about that. But probably what will happen is you'll start doing things, and then you'll start, adding features or making changes, and then realize like, oh, wait a minute, this thing is dependent on this other thing, but it's nested deeper down in the hierarchy. So now I have to pull that up. So it's basically just something that you're going to encounter organically as you write React apps. And there are also, while I'm saying this, you don't really need to worry about it, but there are a few things that you can use to like centralize state. One which is built into React is called the context API, which we'll look at briefly, like in the last week, in the 3rd week of React. And there's also third-party things like Redux. If you've heard of Redux, it's basically a way of centralizing state. So if you have all these components, I mean, we don't have that many, but you can imagine an app with a ton of different components and blah 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 blah. So managing state gets tricky. So one way of making that simpler is basically by putting all that state in one place, or at least putting some of that state in one place. But for now, yeah, we don't have that escape hatch. And Redux, if you think Redux is gonna make your life easier, you're kidding yourself.
Oh, well. And then one other question. I kind of thought the goal for app, if you could go back to app.jsx, like I thought you kind of wanted to keep it super clean to where it just kind of, let's see, I don't know how
Yeah.
much. So only as components, like would you then just have like a child of to app that then just kind of handles all this, and then app.jsx just returns that child? So it's like just creating one more layer, or is this kind of fine too, I guess?
Yeah, so that's a great question. So yeah, I think ideally app should be as dumb as possible. Should really just be like an entry point. So it just renders some components which then do all of the other stuff. So we can definitely change this hierarchy. So right now it's app. So we could imagine this app has other, other components or other, let's say like modules of components aside from just to-dos. So we can just add another layer. So we can add like a wrapper, a to-do wrapper. So I'll do that right here. And then in to-do wrapper, so to-do wrapper will basically do all of this stuff. So I'm just gonna actually copy this, and to-do wrapper is gonna handle all that, except it's gonna be called to-do wrapper. And the imports, it's at the same level, so we'll have to change the imports here. Okay, so this should all work exactly the same. And now in app, I can simplify this. So all I have to do is import to do wrapper. And I can get rid of all this. And I don't need state anymore. And I can do to do wrapper, and that doesn't take any props, at least right now. Okay, so again, everything should look and work exactly the same as it was before. So let's make sure. Okay, so it looks like it's working, but I've changed the hierarchy now. So app is dumb. App doesn't have any state. It doesn't take any props. It calls or renders to do wrapper, and to do wrapper has all of the state. Let's say that any to do component, any state that might be common to other to do components, and we could expand this. So we could make a to do. We could have we could add all kinds of other things here to make this look nicer, to package it up, to add more functionality. But to do wrapper state will have state that might be common to other to do components. It doesn't take any props, at least now. We could change that if we needed to later. And then everything else just works exactly the same. All right. Any questions or comments? But the basic idea is this can be kind of overwhelming at first. It's React, it's a new thing, et cetera, but you really just need to focus on three concepts: components, props, and state. And everything else basically follows from those three things. All right. Let me stop the recording.